The atom is one of the most crucial concepts in both chemistry and science as a whole. Our journey starts in ancient Greece with a philosopher named Democritus who proposed the idea that everything is composed of tiny particles called atoms, which is derived from the word atomos, meaning indivisible in Greek. However, this concept remained purely philosophical without any concrete evidence. Progress in atomic theory was hindered by another philosopher named Aristotle, who introduced the theory of the four elements earth, fire, water, and air, and this dominated Western thought for centuries. The idea of the atom was resurrected by John Dalton, who presented his atomic theory that matter is made up of tiny indivisible particles and each element having its own unique properties. J.J. Thomson expanded on Dalton's theory, discovering that there were electrons within the atom. He envisioned the plum pudding model, where negative electrons were embedded in a positive sphere. Then, Ernest Rutherford's gold foil experiment shattered this model, revealing the nucleus, a tiny positively charged core with electrons orbiting around it. Niels Bohr then proposed the Bohr model, suggesting electrons occupy specific energy levels or shells and can jump between these two by absorbing or emitting energy. The 1920s brought quantum mechanics, a revolutionary theory describing atomic and subatomic behavior. Electron shells are akin to layers of an onion, where electrons reside in specific energy levels around the nucleus. They prefer inner shells before outer ones due to electromagnetic forces. Quantum numbers are assigned to each shell, indicating capacity, and electrons gain energy moving outwards as inner shells are closer to the nucleus and are held together more tightly. Quantum theory also explains energy emission. When an atom absorbs energy, electrons jump energy levels and then return to emit light. This light's wavelength and frequency are inversely related, and you multiply these two to get the speed of light. Electron orbits were replaced by subshells, S, P, D, and F, with specific orbital capacities, and each orbital accommodates two electrons with opposite spins due to the Pauli exclusion principle. So an example would be carbon's electron configuration, which is 1s2, 2s2, and 2p2. The first shell, n equals 1, holds the 1s subshell with 2 electrons, and then the second shell, which is n equals 2, includes 2s, 2 electrons, and 2p, 3 orbitals with 2 electrons. So in conclusion, the atom with its puzzling behavior has revolutionized science as a whole and has led the way for many new discoveries in quantum mechanics and in just chemistry, physics, mathematics as a whole.